Hello everyone, it's really good to see you here. So today we are going to solve Hello everyone, it's really good to see you here. So today we are going to solve a GFG problem, which is number of 1 bits, or we can say number of count of set bits. So here we have given an integer n, and we have to return the count of set bits, that is total number of ones that are present inside that integer n in the binary representation of it. So let's dive into its approach part. So the first very naive approach which we can follow here is that, let's suppose we have given an integer n which is 6, so we can represent it as 110 in a binary form. So what we are going to do is we are going to take AND operation with our number, and uh, that AND operation value should be added in our count. So if the value of AND is 1, that means uh, the count is 1, and if it is 0, then we are going to add 0 in our count. So let's suppose 110 is here, and if we take an AND with 1, then what we are going to do is we are going to get 0 everywhere, right? So that's why our count is 0 initially. So here count is 0, and now what we do, we just left shift. So left shifting means that we are going to not consider the last bit. So now our new n is 1 which is 3 in decimal number. So now we are going to make or take AND with 3 and 1. So we are going to get 1 because 3 is represented something like this, and when we take AND of it, we are going to get 0 here and 1 here. So since 1 is occurred, so that's why our count is now 1. Now again, after doing that, if we left shift this 3, then we are going to reject this last 1, and we are going to get 1. Now 1 and 1 is also 1, so we are going to add that result. So now our answer is 2, and this is the required answer which we have to actually return. But in this case, we can actually optimize this approach. This is a quite easy approach which we can implement. But in Brain's Kernan's algo, what we do, so here uh, it is an algorithm. So if we have to count the total number of set bits, what we are going to do is we are going to take integer n and an integer n minus 1, and we are going to take AND of both. So let's suppose, and till the point this algo works, so now our new n is basically the result of AND of both the operation. So that is 100, which is 4 in our decimal number. So once we got n as 4, so in the second iteration, what we do, we just take an and between n and n minus 1. So n is currently 4 and n minus 1 is 3. So and of it will give 0 0. So till this point, when the value of n, which is now this one, so when the value of n is greater than 0, then only till that point we have to run a while loop, and if the value of this is equals to 0, so that particular number of iteration is basically representing the total number of set bits, and this is an algorithm. So this is in Brain's Kerningham's algorithm. So let's try to uh, code this up. So here you can see that firstly in C is basically 0, and it is going to like it is going to add 1 each time we can able to successfully run our while loop. And int x, so int x is not used actually here. So what we do, while our n is greater than 0, what we make n as n and n minus 1, and we just increment our count, and once our n reaches to 0, we just return C. So let's try to submit this up. So this is the solution for the problem number of 1 bits using the Brain's Kerningham's algorithm. And if you want to assist the code, then you can check the GitHub link given in the description. And this is it for this video. Thanks for watching. But do like, share and subscribe. I hope this helps. Thank you.